It is also called as a first canonical form. Now the next one is the echelon form. Remember, what is the difference? Echelon form, or which is also called as a second canonical form, to identify rank of the matrix. So actually the 50% work is less. 50% work is less. Okay. Suppose, once again, I will start with A is a matrix of order m by n, same. A11, A12, dot dot, A1n, A21, A22, A2n, continue, AM1, AM2, and AMN. This is a matrix of order m by n. I am clearly audible now?
Yes, sir.
Yes, sir.
And suppose rank of the matrix is again R. Then, so to reduce this matrix to echelon form means what you have to do? See, you have to reduce this matrix to the echelon form. For echelon form, you have to apply only column transformation. I will use the word only, sorry, row transformation. Only row transformation. Row transformation, and reduce this matrix in such a way that where in short, the definition, this matrix is in the upper triangular. The elements may be, I will write A11 dash, A12 dash, and so on, A1n dash. New elements you are getting. Huh? Second row, 0, A22 dash, and so on, A2n dash. Third row, like that. So here, first R rows forms an upper triangular matrix. First R rows, if you consider this as a diagonal entry, then first R rows forms an upper triangular matrix. And the remaining rows are identically 0. Remaining rows are identically 0. In short, when you are reducing the matrix to the echelon form, you have to reduce this matrix to the upper triangular form by applying only, remember this part, only row transformation. Don't apply column transformation. So in this case, suppose the new matrix I will call as a B. This matrix I will call as a B. So here, matrix A is equivalent to B because the matrix B you are obtaining from a matrix A by applying elementary transformation. So that elementary transformation is only row transformation. So that's why we may use the word row equivalent matrices. Row equivalent matrices. A and B are called as a row equivalent, particularly because you are applying only row transformation. Now see, question may arise. If you apply column transformation, rank remains same, you will get the same answer. But when you are applying the echelon form, you have to apply only row transformation. Be particular, see the definition. I will reduce the font, or I will increase the font. Yes, it is. Now I think it is fine. Now see, so what is the echelon form of a matrix? So in this definition, we have started with, so let A be a AD matrix with rank R, Then the matrix B, which is obtained from matrix A. So how we are obtaining matrix B from a matrix A? By applying only row transformation, That's why these two matrices are called as a row equivalent matrices. Such that first condition says that one or more element. सुरुवातीचे जे R rows असणार आहे. Meanwhile, I will use some Marathi words also. सुरुवातीचे जे R number कुठनं आलाय? R is nothing but the rank of the matrix. That is assumption. So first R rows forms an upper triangular form My voice is breaking. Sankalp Patil says that voice is breaking.
No, sir, no.
Okay, fine.
No, sir.
Means you may have, okay, you may have network issue, Sankalp. Please check. Okay, I will continue. The definition is the exact definition of the echelon form. First, I have started with the matrix A. Let A be a matrix. Then the echelon form of A is a row equivalent matrix B of rank R with the following properties. One or more element in each of first R rows are non-zero and these R rows forms an upper triangular forms. ठीक है, रँक हा आर आहे. सेम थिंग आय विल रिपीट इन मराठी फॉर सम स्टुडंट्स. ओके, रँक हा आर आहे म्हणजे पहिले आर रोज अप्पर ट्रँग्युलर फॉर्म क्रिएट करायला पाहिजे. ॲट द सेम टाइम these are rows having at least one non-zero element. त्यात झिरो रो घेऊन चालणार नाही. So first R rows forms an upper triangular form with at least one element is non-zero. कमीत कमी त्याच्यापेक्षा जास्त असेल तर चालतील. And second condition says that after that R rows, सुरुवातीचे R non-zero rows असणार आहेत. After that R rows, remaining rows must be identically zero. What is mean by identically zero? All the elements in that remaining rows after that R rows must be identically zero. Then how to find rank of the matrix in the echelon form? So after reducing the matrix or after reducing this matrix to the echelon form, rank of the matrix is nothing but the number of non-zero rows present in that matrix. You can read this. The rank of a matrix in the echelon form is equal to the number of rows containing non-zero element, or in another words, you can say number of non-zero rows in the echelon form is nothing but the rank of a matrix. So for example, I will write one particular, okay. I will write a matrix, whether this is a echelon form or not, you have to identify. Okay. So I will write a matrix with first row 1, 0, 2, 4 and -1. 0, 1, 4, 2, 3. 0, 0, 1, -1, 0. 0, 0, 0, 0, 0. Okay. Suppose this is the first example. What is the definition? First, I will fix the diagonal entry again. Okay. First, I will fix the diagonal entry. The elements below diagonal all are 0. Now, in this case, in echelon form, the diagonal entry may be different. I will take a second example. Just a minute. I call from office. Just a minute. Elements below diagonal all are 0. After that, one more condition you have to check. Now, first non-zero element in the first row. So this is the first non-zero element. And element below to that all must be 0. Okay, this also condition you have to verify. Second one, second non-zero element in the second row, this one. The element below to that all must be equal to 0. Next, third non-zero element, आणि त्याच्या लेफ्ट साइडचे पण सगळे 0 पाहिजे. Non-zero element below to that all equal to 0. Okay, below to that all equal to 0. Now next one, there is no element, non-zero elements. So this is in the echelon form. And what is the rank here? Suppose this matrix is A. Yes, anyone?
3.
3. Because non-zero rows are, this is non-zero row, that is 1. This is non-zero row, that is second. This is non-zero row, that is third. So you have to count number of non-zero rows. So rank of this matrix is 3. Still students are joining. Okay. Similarly, second example, suppose. Second example, I will write a matrix B. Directly I will use the elements like this. Okay. 0, 0, 2, 3, 4, 1, 0, 0, 0, minus 1, 2, 3, 0, 0, 0, 0, 4, 0, 0, 0, 0, 0, 0. Suppose one more row, 0, 0, 0, 0, 0, and 0. What is the order of the matrix? Anyone?
0.
Order.
5 cross 5.
Yeah, there are 5 cross 5. Yeah.
Sorry, 6 cross 5, sir.
1,
5.
2, 3, 4, 5. 1, 2, 3, 4, 5, 6. 5 rows. Number of rows sanga. 1, 2, 3, 4, 5. Number of rows.
5.
Cross 6. Okay. Now, for the echelon form, again the same thing. What happened? This matrix started with the initial element as a 0. When you are fixing the diagonal entry in the echelon form, consider the first non-zero element, this one. And like this, you have to fix the diagonal entry. Like this, you have to fix the diagonal entry. इथून सुरुवात करायचा. Otherwise, the second definition, काय पाहिजे? In the first row, see the first non-zero element. The first non-zero element is 2. And below to that, all element must 0. And left side of that column, all should be 0. आहेत का? Yes, this is also 0. This is also 0. Okay. Now the second row, the first non-zero element is -1. Below to that, all must be 0, and left side of that, all 0. Next, non-zero element is 4. Below to that, and left side to that, left side means what? This one, that also equal to 0. That means the given matrix is in the echelon form. This matrix is in the echelon form. Now number of non-zero rows, 1, 2, and 3. So the last 2 rows are identically same. So what is the rank here? Suppose this is B. Rank of the matrix B. Yes. It is visible now? Yeah. What is the rank?
3.
3.
2 or 3?
3.
Yeah, number of non-zero.
3.
3. Okay. म्हणजे ह्यामध्ये तुमचा वर्क जो आहे, your work is 50%. You are not applying column transformation to reduce the elements which are above diagonal. So when I am using diagonal entry, that means the understanding is clear how diagonal entry you are fixing. Okay. So why it is important to apply row transformation? Now the next point is solution of system of simultaneous linear equations. And when you are solving system of linear equations, if you apply a single column transformation, you will get wrong answer. Rank is correct. Rank बदलणार नहीं. Rank is same, but solution not remain same. So that's why when the particular method is given while finding the rank, you have to apply that particular method only. If method is not given, you are free to choose either normal or echelon. Okay, in the examination point of view, I am telling whether you have to apply normal form or whether you have to apply echelon form, that part is not given in the statement. In that case, students are free to use normal or echelon form, any method. If the particular method is given, you have to apply that particular method. And when you are solving system of linear equations, there you have to apply only echelon form to find the rank. There you have to find only row equivalent matrix. Is it clear? Reply, yes or no?
Yes, sir.
I will continue the
Yes,
example.
sir.
You will
Yes,
get
sir.
more clear idea. Yes, fine, thank you. So take down a question. Question is common. Reduce the following matrices, just like a normal form. Reduce the following matrices. Reduce the following matrices. matrices to echelon form. To echelon form and find rank. Okay. So the first example. Suppose the matrix A, name may be given or not given. First one, the elements are 1, 2, sorry, this is -2, 1 and 0. There are 4 rows. There are 4 rows. Second, so first row I will write 1, 2, 3 and -1. -2, -1, -3, -1, 1, 0, 1, 1, 0, 1, -1. So before proceeding, one simple question, I want feedback from your side. Anyone can unmute and speak. Rajin Momin, Rajin Momin. Okay, Rajin Momin has joined. Rajin Momin, can you unmute? Momin. See what happened, general thing I want to discuss with 1 or 2 minutes. What happened? It's almost 10:52 and lecture has been started 10:30. Rajin Momin just admitted to the meeting. मी आता शिकवायच्या फ्लो मध्ये आहे आणि ठीक आहे, I am having 2 screen, 1 screen I can see the students, those who are joining, and whatever I am presenting that I can see on another screen. पण शिकवताना थोडंफार डिस्टर्ब होतो, त्याची काळजी घ्या. सगळ्यांना मी म्हणजे प्रेमानं सांगतोय, माझं जर लेक्चर 10:30 ला असेल तर मी प्रिपरेशन 10 o'clock ला स्टार्ट करतोय. बिकॉज स्टुडंट्स मे जॉइन मॅन्युअली, आय हॅव टू ऍडमिट देम. दॅट्स वाय आय लॉग इन ॲट 10 AM. So sufficient time was there, half an hour. So between that you can join. Now once the lecture started, everyone should be ready. At 10:30 there is no manual admit. Through Google Classroom also. जनरली वाटत मी शिकवतोय, कोणतरी इकडे पॉपअप मेसेज होतोय, वांट टू ऍडमिट, पुन्हा त्याला ऍडमिट करा, पुन्हा माझा लिंक तुटतोय. हे नको आहे ना शिकवताना. रजिन आहे का मोमीन? काय अडचण असू शकते बाळा, काय अडचण मी जनरल सांगायला लागलोय. ऍटलीस्ट फॉर माय लेक्चर. So tomorrow also I am having at 10:30. Yes, Rajin.
Okay, sir.
Rajin means it is applicable to all also. कारण आतापर्यंत मी 10-12 विद्यार्थी ऍडमिट केले मॅन्युअली. सो 10:30 I am having lecture. So morning at 10:15 माझा लॉग इन असणार आहे. You may have some technical problem to join the classroom. In that case, suppose you are using a personal email ID. So already I told you, before 10 minutes join, before 5 minutes join. एकदा शिकवायचा फ्लो चालू झाला ना, पुन्हा बॅक एंडला जाणार, इकडे येणार, थोडं डिस्टर्ब होतो, तो लिंक तुटतोय. ओके, दॅट इज अ वन थिंग. सेकंड थिंग, so last time for the higher classes we are using a live classroom through camera. Again, that some visibility and voice problem is there. But in this now for this semester or for this class I am using a OneNote. Whatever platform I am using, I am presenting, that is called as a OneNote. I think you are feeling like just classroom teaching right now, or any suggestion from your end? We are at the beginning, that's why I am asking feedback from your end. You can tell anything, whatever you want. मराठी मध्ये शिकवायला पाहिजे, काही विद्यार्थी असू शकते. Same thing we can repeat in Marathi also, don't worry. If any feedback is there specific, you can mention, because we don't know the nature, who are there. Only names are in front of me, and accordingly you are teaching, whether you are getting, whether you are understanding. Okay, one message in the chat box. Okay, it is fine. This is good, sir. Okay. So any specific feedback you want to, or that should be changed, or something like that should be happen. असेल तर सांगा, नसेल तर it's okay. I will continue this method only. Okay, this is best because, okay, fine. So meanwhile, anyone feedback they want to give, then it's fine. Because what happens for board classroom, we are having again limitation, but here we are having a technology. So presentation can be done more effectively. Now it's fine then. Okay. Thank you for your feedback. So the next one, first example, in the same manner, don't write anything. Second example onwards, you have to write simultaneously. So first example, listen carefully. So try to understand the process. So for solution, once again, I will start with the given matrix. Okay, once again, I will start with the given matrix. So already name is given in the statement. If not given, start with A. So the matrix A is first row, 1, 2, 3, -1, -2, -1, -3, -1, 1, 0, 1, 1, 0, 1, 1, -1. Okay. Now fine. I will scroll up little bit. You can zoom your screen if text is not big. Vedika want to join. Okay. Okay, continue. So generally in two examples, I explain the method. When the matrix is given for the first row, you have to start with first non-zero element. So generally 99% first element will be non-zero. This is the only 1% chances where you are having first element in the row is non-zero and below to that is also non-zero. Okay, means if all the elements in column 1 are 0, in that case you have to think of the second. Now here the first element is non-zero. Sorry, first element is non-zero. That's why I will fix the diagonal entry. Okay, I will fix the diagonal entry. So you are reducing this matrix to the echelon form. That means you have to apply only and only row transformation. And in such case, it may not be possible to avoid the fraction in echelon form because you are applying only row transformation. Na? It may not possible. Now our first target is, if it is just like a echelon form, if it is possible to obtain this element is 1, it's okay. Not necessary for the echelon form. So our target is the elements which are below to A11, these elements you have to reduce to 0 by using R1. This element may be 1 or may not. Only and only row transformation. Yes, what are the transformations?
R2 plus
R2
2
plus 2
R1 to
R2
R1,
plus 2
R3
R1,
minus
R3 minus R1.
Correct. R3 minus R1. So the new row equivalent matrix. So these two transformations shows that change in second row and third row. These two row changes. So the new equivalent matrix where first row no change. That is 1, 2, 3 and -1. Second row no. Oh, okay, you have to apply the transformations. What you have to do? You have to multiply by 2. If required, I will write here. So R2 is 1, 2, 3, -1. And 2R1 is 2, 4, 6, -2. And their subtraction. 1 minus 2. Sorry. Their addition, something I written wrong. Just a minute. Huh? Just a minute. Something I written wrong. Just a minute. R2 is -2, -1, -3, -1. 2R1 is, you have to multiply by 2. That is 2, 4, 6 and -2. And their addition plus 2 minus 2. -1 plus 4, -3 plus 3, sorry, plus 6, -3. Okay, the resultant element, I am expecting calculation from your end, 0, 3, 3, -3. Now for the third one, R3 minus R1, 1 minus 1, 0 minus 2, 1 minus 3, 1 minus 3, correct? Huh? 1 minus minus. And the last one, 0, 1, 1, -1. Now again, the diagonal entry in the matrix is, so here don't consider every time that diagonal elements A1, 1, A2, 2 must be required as a 1. If easily it is possible to obtain that elements as a 1, then it's fine. Then it's fine. Okay, anyone can suggest? See, first step. This is the first non-zero element in the first row. The elements below to that all are 0. Now, come to second. This element is a non-zero. So our aim is to reduce these elements to 0. What is your transformation? Yes. You can observe only row transformation or to apply. The elements in the second row, 3, 3, 3 or minus 3, 2, 2, 2, minus 2 or 1, 1, 1 like that. What is your suggestion? Only row transformation. Siddesh. पटकन सांगायला पाहिजे यात वेळ जातो ना A34 should be 0. Okay, I am asking the particular transformation. What kind of transformation you are going to apply? सांगा पटकन. सेकंड रो ऑब्झर्व केला तर काय करता येईल? ऑल द एलिमेंट्स
R3 plus R1.
R3 plus R1, it's okay, fine. If you are obtaining that A22 element is 1, it's fine. So one thing you can observe now. So you are solving more example. Yeah, R2 divided by 3. Because all the elements are multiple of 3 na. But at the same time, I will apply, see the next transformation is, one suggestion is by 1 upon 3 into R3. Similarly, minus 1 upon 2 into R2 also I will consider. कारण का सगळे element minus 2, 2 है ना. Therefore, now the third one is 1, not necessary. New equivalent matrix where change for the third and fourth row, change for the, sorry, third and second, something I written wrong. This is,
Sir, it's 1 by 3 R2.
this is 2 and this is 3. Okay, I will correct it. This is 2 and this is 3. Make me correct if I am writing wrong. R2. This is R2. This is R2. This is R2. Yeah. Now, new matrix. So, change for second and third row. First row, no change. 1, 2, 3, and minus 1. So, if you multiply by 1 by 3, so what you have to do? You have to multiply by 1 by 3. So, 0, 1, 1, and minus 1. Now, the next row, you have to multiply by minus 1 by 2. What is the element? 0, 1, 1, minus 1. So the last one remains same. 0, 1, 1, minus 1. Can you guess the rank here?
3.
Oh no. Again you are telling 3. Okay, continue.
2.
Yes.
2.
Okay, yes. Now see, your diagonal entries. Your diagonal entries. So after getting the elements below to A110, come to these. These elements you have to reduce to 0 by using this element. What is the transformation? R3 minus R2 and R4 minus R2. So the new equivalent matrix where change for third and fourth row. First row 1, 2, 3, minus 1, 0, 1, 1, minus 1. I think the rows are identically same. That's why you will get elements as 0, 0, 0. Is it fine? Whether this is in the Echelon form? Whether it is in the Echelon form? Yes. See again. Don't write, first see the process. This is a diagonal entry. The elements below diagonal are 0. That condition must required. For sometimes you have to verify. So first non-zero element in the first row, this one. So below to that, all are 0. Condition satisfied. Second non-zero element in the, sorry, first non-zero element in the second row, below to that, all elements 0. I think next elements are identically 0. So that is in the echelon form. Now count number of rows. How many rows are there? Number of non-zero rows?
Two.
Which is required echelon form. ECHE spelling. Echelon form. Therefore, rank of the matrix. Why it's not working? Just a minute. Rank is equal to 2. That is a required answer. If you compare with the earlier case, half work is reduced. The rank of A is 2. Any doubt, any question? If your mic is not working, you can write in the chat box. Any doubt, anything, questions from your side? Okay, fine. Continue with the second example. So before that, I think last lecture I given some examples to complete as a homework. Anyone done it? Normal form. So let the matrix A is, the given matrix A is 1, 3, 2, 2, 1, 2, 1, 3, 2, 4, 3, 4, 3, 7, 4, 8. Now, again, this first one is a non-zero element. That's why I will fix this diagonal entry. So our target is to reduce these elements to 0 by using this element. Yeah, again, it's not working. So continue the calculations. One note is not working, system getting hang. So by R2 minus R1, correct? R3 minus 2R1 and R4 minus 3R1. So these transformations shows that change in the second row, third row and fourth row. First row, no change. So in this case, only row transformation. You are applying column, then definitely will get 0 marks. That means you are not understood. First row, 1, 3, 2 and 2. Now apply the transformation. Apply the transformation. So if you did the calculation, tell me.
0 minus 1 minus 1 1.
Okay. Verify. I will write 0 minus 1 1 minus 1. Correct. Now next multiply by 2 and their subtraction. 2 minus 2 0. 4 minus 6. Oh, sorry. 4 minus 6 minus 2. Correct now?
Sir, in second row, minus 1 1.
Okay. Now it's okay. Third one, minus 2, minus 1, 0. Verify calculations. Next, multiply by 3, 0.
Minus 2, minus 2, minus 2.
Which one? Fourth row?
Yes, sir.
Minus 2, minus 2, 0. Right? Huh? Verify the calculation part. Huh? This is again diagonal entry. After that, these elements to 0. Pi. R3 minus 2R1, correct ka? Sorry, R3 minus 2R2, R4 minus 2R2. Is it right?
Sir, R4 0, minus 2, minus 2, minus 2.
8 minus 6. Okay. I have to calculate then. Okay. This one is minus 2. Then fine. So change for 2, 2, 0, minus 1, 1. So multiply by 2 and their subtraction. 0, 0. Their subtraction, na? 1 minus minus.
हेलो सर
Yes.
सर वो वहाँ पे सिर्फ 2 आएगा सर R4
Correct. Okay, I will perform the calculations. ठीक है. अभी ठीक है ना?
Yes, sir.
Okay, next one. Suppose if you are applying R4 minus to R1, then definitely this is 0, this is 0, minus 2 and minus 2. 2 and 2, their subtraction. Now in this case, this is your diagonal entry. Can anyone suggest what will be the next calculation? Or what we have to do next? Just quickly, Shivam Zazu.
R2 divided by -1.
का बरं? Sankalp Patil, those who are giving the elementary transformation, I will ask one question. आता जो मिळालेला मॅट्रिक्स इचेलॉन फॉर्मला आहे का? What is the echelon form? First thing, the elements below diagonal all are 0.
Yes.
Yes, sir.
After that,
Sir.
yes, this is first non-zero element. Again, first non-zero element in first row, below to that all are 0. बरोबर आहे? First non-zero element in the second row is this one. Below to that all are 0 and left side is also 0. First non-zero element in the third row, this is the third row, and below to that all are 0. And fourth row is identically 0. म्हणजे जे काही तुमचे लाईन्स गेलेले आहेत, लाईन्सवर सगळे एलिमेंट्स 0च आहेत ना. देयर इज नो नॉन झिरो एलिमेंट. मीन्स दिस इज अ इचेलॉन फॉर्म और फर्दर वी हैव टू प्रोसीड. Which is echelon form of a given matrix, Therefore, what is the rank? At least tell me.
3.
3.
Correct. Rank of A is 3. This one is a first non-zero row. This is a second non-zero row. This is a third non-zero row. So the rank of the matrix is 3. Okay, that's completed the example. Comparatively, echelon form is easy. So one example I will take from the last class, that homework I was given, this one. Is it possible to copy? Okay, this example I will take. You told that answer is 3. We will verify that. This example I will copy, Control C. Why it is not working properly? Just a minute. Yeah. Okay, this is the next example. Number 3, suppose. Example number 3. You told that answer is 3. Once again, I will write the matrix as a A. You have to suggest me the calculations. Still 15 minutes are there. We can complete one more example. So let A is equal to, as it is the given matrix, 2, 3, minus 1, minus 1, 3, 1, minus 1, minus 2, minus 4, minus 6, 3, 1, 3, minus 2, 5, 6, 3, 0, minus 7, and 2. So I want suggestion from your end. Whatever you are telling, that transformation I will apply. ठीक है?
R1 minus R2.
R2 minus R1.
R1 minus R2. It's fine. Otherwise, anyone can interchange R1 and R2 also. I will continue with you.
R1 2.
R1, R2 interchange also possible. R1 minus R2 is also possible. Which transformation I should apply? Quickly reply.
R1, R2.
R1 2.
Okay, R1 and R2 interchange. Change for the first row and second row remains same. That becomes 1, minus 1, minus 2, minus 4, minus 6, 2, 3, minus 1, minus 1, 3, remaining as it is 3, 1, 3, minus 2, 5, 6, 3, 0, minus 7, minus 2. Okay. It is not mandatory to apply that diagonal entry is 1. But easily if you are getting in the, it is better. Okay. This is a diagonal entry. Now the elements which are below diagonal, these elements you have to reduce to 0. Tell me transformation fast. By
R2
R2
minus
minus
R1,
2,
R3
2 R1.
minus 3 R1, R4 minus 6 R1.
correct. R3 minus 3 R1 and R4 minus 6 R1. So the new matrix, change for second, third and fourth row. First row, no change. That is 1, minus 1, minus 2, minus 4 and minus 6. Multiply this row by 2 and there's a subtraction. Please unmute. 0. म्यूट करा कोण आहे बघा त्याचा आवाज येतो 0 3 minus minus 2 minus 1 minus minus plus 4 minus 1 plus 8 verify the calculations 3 plus 12 calculations are correct verify बरोबर आहेत का कोणतरी कन्फर्मेशन द्या
Yes, sir.
okay
Yes, sir.
next you have to multiply by 3 and their subtraction so again 0 1 minus minus
4.
3 minus minus plus 6 something no barabar
9.
minus 2 plus 12
10,
5 and 18
23,
okay verify the calculations and next one you have to multiply it by 6 and their subtraction 6 minus 6 minus 3 sorry plus 3 minus minus 0 minus 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 7 plus 24 2
38.
38 okay verify the calculations huh? I am feeling this is 5 plus 4 9 3 plus 9 12 7 plus 17 okay it's fine now after that this is your diagonal entry okay this is your diagonal entry now you suggest me the calculations you suggest what will be the transformation oh fast
R2 minus R3.
okay continue with R2 minus R3 if you are applying elementary transformation then no problem why R2 minus R3 so the new equivalent matrix change for second row only first row that is 1 minus 1 minus 2 minus 4 minus 6 now apply the transformation 0 minus 0 5 minus 4 5 minus 4 3 minus 9 7 minus 10 verify the calculation 15 minus 23 किती येते
Minus 8.
Minus 7.
minus 8 okay 0 4 9 10 23 0 9 12 what is the element can anyone repeat 12 7
17, 38.
17 and 38 yeah 17 and 38 now yes I will fix the diagonal entry so this is diagonal entry after that the elements below these now tell R3
Minus 4 R2.
correct
R4
R4.
minus 9 R2.
9R2. So change for third and fourth row. So the new equivalent matrix. First two row, no change. 1, -1, -2, -4, -6, 0, 1, -6, -3, -8. Multiply by 4. Second row, you have to multiply by 4 and their subtraction. 0 minus 0, 4 minus 4. मला जर सांगा 9 plus 24. So 33 na?
33.
Yes.
33.
9 plus 24. After that 10 plus 12.
22.
22.
After that, here if required, I write the element. It work as a calculator. 23 plus 32. 55?
55.
Yes. Now the next, you have to multiply by 9. Right now? You have to multiply by 9 and then subtraction. Obviously, this is 0. This is 0. Okay, here I will write. What is the
66.
element? 12 minus minus become plus 6 into 9.
54.
66. Correct. Next. 17 minus minus become plus 27. Is it right? Is it right? 44.
44.
Now the last
110.
110. Verify. Last one is 38 minus 5 s. 8 9s are 72 na? 110. 110. Yes, 110. Okay. Now again, this is your diagonal entry. Let me know your calculations. What do you suggest?
R3 divided by 11 and R4 divided by 11.
ठीक है. R3 divided by 11 and okay, I will write the transformation. What you have suggested. Hello. Just a minute. Something elements put together. Just a minute. I will undo whatever I did. Not possible. Element gele. Okay. What is the first row here? 1. Something wrong here. 1 minus 1 minus 2 minus 4 minus 6. This is the matrix. Okay. What is the transformation? What you done? By 1 by 11 into R2. Next one?
Sir, R3.
R3. Okay. Next. R4 ला कितने multiply करना है?
22.
22. Okay, fine. So the new equivalent matrix where change in third and fourth row. So the new matrix. First row 1 minus 1 minus 2 minus 4 minus 6 0 1 minus 6 minus 3 minus 8 0. Tell me the element fast. 3 2 5 0 0 3 2 5. So tell me next. Fast.
R3 minus R4.
Yes, that's it. Not necessary to obtain that element as a 1. So our target is to reduce this element as a 0 and both row are identically same. Therefore, by R4 minus R3. R4 minus R3. So the new equivalent matrix where first 3 rows no change. That is 1 minus 1 minus 2 minus 4 minus 6 0 1 minus 6 -3, -8, 0, 0, 3, 2, 5, and fourth one is identically 0. Right now? So what is the next calculation?
Rank is 3.
Okay, this is a echelon form that you have to identify first.
Rank is 3.
Okay, directly I will write. Rank of the matrix A is equal to 3. That is number of non-zero rows in that column that you identified. Okay, that you identified. This is the first row. This is the first. This is the second. This is the third. So again, few examples for homework. Take down. HW that you have to complete. Under the same title, you can continue with the number. Fourth example. 1, 3, 1, 3, 4 and 3, 3, 9, 12, 9, 1, 3, 4, 0. That is the first matrix. And fifth one, 2, -1, 3, 4, 0, 3, 4, 1, 2, 3, 7, 4, 2, 5, 11, and 6. Okay. So again, tomorrow first I will continue with these homework examples. Only 2 examples I have given.